Okay, so review problems. Here we go. And we'll touch on a little bit of everything. And if y'all have something else that you would like to see, then let me know and we'll work those out too. But I think one of the first problems it's going to ask you to do, ask you to work through, it's going to ask you to divide. And maybe starts off something like this. Okay, biggest thing, if you have the, now if it was, and we'll get to one in a minute, that was a little bit easier dividing problem, but this one, if it's multiplication or division, either one of the two, then basically here's what you're going to have to do. You're going to have to do two things. You're going to have to factor and you're going to have to cancel. That's what it comes down to. Before the division problem, before we do anything at all, that's where we're going to go keep it, change it, flip it, like you did back in middle school. You know, keep the first fraction the same. You're going to change the division to multiplication, and then you're going to flip or take the reciprocal of the second fraction. Okay, so when we do that, so now we have x squared minus 9 over 4, and then times 8 over 2x squared plus 6x. And once it's a multiplication problem, that's actually where we get to do the factoring and the canceling. So anything that's got an x on it, you're going to have to factor. And it may be a couple of different things, but we'll kind of see here. Now, and if you want to kind of, as soon as you do that, this one you may look at it and go, well, I've got 4 and 8. Why not just go ahead and divide those two? Okay, sure, you can. 4 will go into 4 one time. 4 will go into 8 two times. But you can just go ahead and simplify that just like you've been doing for years. Okay, with the x's, that's the part you have to factor. That's where that was that first week of our second week when we did the factoring review. That's where all that comes back in. You have to recognize that with x squared minus 9, that's the difference of two perfect square numbers. And one thing that you can kind of do, and this is something that they should have talked about but probably didn't, but when you factor things, whatever the power is of your biggest power, most of the time that's how many different parentheses that you want. It's not always that way, but that's usually a good case. So if it's x squared minus 9, that means we're going to need two parentheses. The perfect square of 9 is going to be 3 and 3. So we'll make one a plus and one a minus. And if you want to go ahead and put that 1 there for a placeholder that we had here for this one, you can go ahead and leave that there. Probably don't need it, but you know, it never hurts. Never hurts to leave a 1 in there just in case. Yes, sir.
I apologize. I got lost. Where did the 2 come from?
Oh, we were dividing 4 here, so we divided 4 into 4 went one time. We divided 4 into 8 and went 2 times. That would just.
We don't cross multiply.
No, here basically with once we get to multiplication, you're going to factor and then you're going to cancel. So, okay. Okay, for the second problem, we had the 2 that was here, so we'll put the 2 back in. And on the bottom part, we do have to factor it. Now, it's a little bit different because of how it's set up, because in this case, they both have an x. So we're going to take the x out here. And 2 and 6, you can divide them both by 2. So divide out both of them by 2. So for this problem here, if you take out the 2 and you take out one of the x's, you've got 1x left over. If you take 6 and divide it by 2, that's going to make that a 3. And if you take out the x, then the x is gone. Yes?
Can you explain what you did with that?
The one back over here? Oh, okay, gotcha. Okay, so this one, for that particular problem, we're doing the 2x squared plus the 6x. The first thing you always want to do whenever you do any kind of factoring is you want to look and see if they both have something. You look for a greatest common factor first. See if there's something that they have in common. Well, the numbers are even, right? They're both 2 and 6. So if they're both even, that means you can divide a 2 out of both of them. And if you want them to do this. Back up for a second. So we're going to figure out the greatest common factor first. So we know we can take it, divide them both by 2. They both have an x. This one's got 2 x's. This one's only got 1. So we can take out one of the x's. So if we had to figure out a greatest common factor for that particular term right here, they're both even, so we can divide it both by 2. They both have an x, so we'll take out one of the x's. Okay, and then to make it factor out, to make it be what you're supposed to do, is that you're going to take whatever your expression is to get it factored out. You're going to put the greatest common factor on the outside. And once you've figured out what your greatest common factor is, you go back and divide both of these things by that greatest common factor. And then whenever you get left over, that leftover is going to go on the inside of the parentheses. So if you do 2 divided by 2, that's 1. If you've got x squared over x, you can cancel out one of the x's here, cancel out that one here. Leaves you with x. If you do 6 divided by 2, that's 3. If you take in that one, and you're going to knock out both of the x's there, so that leaves you with just 3. And if you have 1x, of course, you don't have to put the 1. So then we've got the x plus 3. So that's kind of the thought process you want to go through. Anytime you factor out a greatest common factor, first off, figure out what they have in common, figure out what that greatest common factor is. And then you're going to divide that greatest common factor out. It's basically a reverse distributor property is what it is. This is the answer you had when you had distributor property. You got to figure out what you had to multiply out to get that number that was there. Okay, once you've done that and you've factored everything as much as you can, this is where the easy part comes in. Anything that's the same, that's where you get to go back and knock it out. You can cancel out that x plus 3 and that x plus 3. You've got a 2 here and a 2 here, so you can knock that out. And that will leave you with an x minus 3 on the top and an x on the bottom. And here's where you got to fight the temptation, because a lot of times people will get to this when they go, all right, I don't need the parentheses, so I'm just going to put x minus 3 over x, and then they'll say, oh, I can cancel out those x's. Here's what you've got to do, and this is something that I tell people here in high school when I'm teaching classes at Calhoun. I tell them the same thing. If you have something that's in parentheses like this, even though we got rid of it here, you still have to think about it being in parentheses, and the only way to cancel something in parentheses is to have the exact same thing in the parentheses to go with it. So if you have x minus 3 over x, you can't do anything with this, because to make this cancel out, you'd have to have like this, where you have the exact same thing here and the exact same thing here. If it's at least a little bit different, you cannot cancel those things. So just anytime you've got parentheses, just got to realize you can't take something out of the parentheses and cancel something that's different. It has to be exactly the same when you go through that. So I almost wish they'd let us leave the answer here, because that would make more sense. But when you do that, they go, well, there's nothing, there's no distributive property with this parentheses. You're not multiplying anything. So they say in that case, you can take it away and leave it as just x minus 3 over x. Okay, y'all want to do another one of those? Okay. All right, let's do another one of those. A little bit different, but pretty much the same kind of question here. Let's go with x squared minus 1 over 3. And we'll divide that by 2x minus 2 over 6. Okay, same basic setup with this one. It's a division problem, so before we do anything at all, before you do any canceling at all, you have to rewrite it and make it a multiplication problem. So you're going to keep it, change it, flip it. So we'll keep that as x squared minus 1 over 3. Change that division to multiplication, and then flip this one upside down, so we've got 2x minus 2. Now, if you have a problem that's in the homework or in the test, if it's already a multiplication problem like this, you can just start factoring and canceling. But if it's division, you have to rewrite it first to make it a multiplication problem. Once you're here, now you start factoring and you start doing the canceling, whatever you want to do. Okay, first thing you may go is look at is you may say, all right, well, here's a 3 on the bottom and a 6 on the top. I can divide both of those by 3, so that'll make that a 1 and a 2. Okay, for the other part, this one is another perfect square. It's x squared minus 1 So we make that x, whoop, sorry, x plus 1 and x minus 1. Same thing if this had been, 16, you'd have made that 4 and 4. What if that's a perfect square number that you can do 2 times 2 or 3 times 3 or 4 times 4 to get that number? That's that perfect square we're looking for. This one is over 1, so we'll put that 1 in there just for a placeholder for a little bit. Times, we've got the 2 that was up here for this one. Okay, and the bottom part for this one, we do have to figure out a greatest common factor, which is 2x and 2, which is, again, is just a 2. So if the greatest common factor is 2, that means we're going to divide both of these things by 2 and put that greatest common factor on the outside. 2 divided by 2 is 1x. 2 divided by 2 is 1. And again, we don't need 1x. We can put the x by itself. So for that one, we'll make that x minus 1. Okay, factor it as much as you can. Now you get to start canceling stuff out. You've got an x minus 1 here and an x minus 1 here. That's gone. You've got 2 over 2. So we can knock those 2 out. And again, anytime you cancel stuff out, basically you go back and put 1s in there as placeholders. So for this one on the top, you've got an x plus 1 times 1, which is still just x plus 1. On the bottom, it's 1 times 1 times 1, which is just 1. So this is x plus 1 over 1, which means that's really just x plus 1. Okay, so now we did long division yesterday. There are a couple of long division problems mixed in there, and some of them you have to determine if the steps are correct. Some of them it's just tell me what the answer is, that kind of thing. So if we need to go back and get one of those, we can a little bit. The other division one that we had that was actually a little bit easier version of division than the long division was where you were just dividing by one term. It might have been something like this. Let's go 10x to the 5th plus 4x to the 4th minus 2x squared plus 60. And maybe I'd divide that by 4x squared. Okay, biggest difference on this one is it's not long division, because if we're doing long division, you had to have x plus 1 or x minus 1. It had to be something. If it's just one term on the bottom, this one's actually pretty easy. This is where you take every single number up here and just divide it by the number that's on the bottom. And then from there, it's basically 4 fractions. And you're going to simplify each fraction just as much as you can when you go through those. Okay, and each one of those numbers, it's almost 2 different things. You're going to take it and look at just the number, and then you're going to look at the variable part of it. So if it was 10 divided by 4, and we'll cover up everything here in a minute. If you take the 10 divided by 4, take off the x's for just a minute. If that was a fraction, you can divide them both by 2. So for that part, you can make that 5 over 2. Okay, when you go to the x's, it's really pretty straightforward. You just subtract the variable, or subtract the exponents. You've got 5 on top, 2 on the bottom. 5 minus 2 is 3, so it makes that x to the 3rd. Okay, next problem, same thing. 4 divided by 4 is 1. Again, we may or may not need it. Just depends on how many x's we have or what goes on there. So I would say just do it one piece at a time. You've got x to the 4th and x squared. Subtract the exponents. 4 minus 2 is 2. So it's 1x squared. We don't need the 1, but that's fine. We'll go back and get it later if we need to fix it. Okay, 2 over 4. It's a half, right? You can divide both by 2. So that's minus 1/2. In this case, you've got x squared minus x squared. If you do 2 minus 2, that's 0. If it's x, if you get a 0 for that exponent that's here, that means you don't have to put it. So basically, the x's can't, because the x's would cancel out. So that case, it's just the 1/2. And for the last one, it's 60 over 4. If you check that one you can just do division. 60 divided by 4 is 15. There's not any x's on the top. There's just the x's on the bottom. So if there's no other x's to do, then that one just stays right where it is. Okay, the only thing you might do on that one is they may, oops, that's the third. For that 1x squared, of course, you can just make that x squared. But the answers that you have on this first test, they all should be some type of multiple choice. There might be, if there's one that's a fill in the blank, it's probably going to be an evaluate where there's like one answer we're looking for. Any of these problems like this, it should be a multiple choice where you can go through and do that. So, that would be the only difference is where we had the 1x squared here, that 1 would go away and just become an x squared. Okay, so if you have just the one term, it makes it a little bit easier because you're just going to do it one piece at a time when you go through that. And again, the numbers are just either a whole number or a fraction that you simplify it down to, and then the variables, you just subtract the exponents to get what you need. Okay. Okay, here's something I think that may run. We did this with first block too. Something that may run into a few problems here and there. This is where you're going to solve for a specific variable. We'll do 2, maybe 3 of these just to make sure you got it. For this one, let's solve for h. And if you didn't catch this when you were working through these problems, when you were going through the PLP and going through the different numbers on these, here's the big thing that you have to figure out that you're doing. If you have to solve for h, you've got to figure out everything that happened to h, and you're going to do the opposite. You're going to basically do the reverse of this one. So over here, you've got b times h. That means that when you solve this thing, you're going to have to divide by b. And if it's h divided by 2, that means you're going to have to wind up going back and multiplying by 2. So anything that you do to whatever variable they're telling you to solve by itself, everything you would tell me that you do to it, that means you got to do the opposite. You got to reverse it and go back to this one. Okay, so very first thing I would do on this one, and it doesn't really matter which one you do. You're like, well, what do I do? Do I get rid of the 2 first or do I get rid of the b first? It doesn't matter. Most people don't like fractions, so let's get rid of that fraction. That we're going to take both sides and we're going to multiply by 2. Because if we do that, you got the 2 on the top, the 2 on the bottom, those 2's cancel. That'll give you a 2a equals b times h. And if you have b times h, to get rid of multiplication, that means you need to divide. So we're going to divide both sides by b. That way that cancels out. And now you've got the h by itself. If anybody's had chemistry, you probably had to do some of that in chemistry, right? When you solve for, yeah, you solve for specific variables because you got to figure out what's happening to it, what's being influenced to it. So yeah, that's what people go, wow, why are we doing math in science class? I'm like, that's where the application is. You figure out what it is here, you go apply it with the science so that you don't blow stuff up. Or sometimes you do want to blow stuff up, but you got to do it in the right amounts.
Do you know who created letters and math?
Not sure who did the variables first. Egyptians? No. Sometimes after the Egyptians. Don't know who exactly was the first one with that one.
Doesn't matter.
All right, let me give you a couple more of those just to make sure we got it. All right, this is one that it looks kind of bad, but when you actually do it, it's not near as bad as you think it is. So let's do R, capital R, times R1 plus R2. That's going to equal R1 times R2. And we're going to solve it for R. Okay, and again, here's what the question you want to kind of look at in your head. What are we doing to R? If you read this out, what's the math in this? It's R times R1 plus R2, right? If you look at just the math part of it, it's R times on that one. So if it's R times, to fix it, that means we need to divide by whatever we're multiplying by. Okay, so when we do that, again, same thing in parentheses, so we can cancel those two things out. So capital R equals R1, R2 over R1 plus R2. And then that one, well, now that one's a little bit different because that one's R1 times R2. And that's what we're saying, that if you've got one little bitty thing, even one little thing different, you cannot cancel those. So that's a plus, that's multiplication. So for that one, yep, got to leave it right there. No, you're good. That's why we talk about it. That's why we go over these. So just that one little difference, you know, that's all that made the difference on that one, of why you were able to cancel one time where you're not able to on this time. Okay, that was a little bit more of a sneaky one. Let's give you one that's got a little bit more work to it. And this will be the last one we do on these for solving equations for the one specific variable. Okay, so for this one, let's do what we're going to solve for here. Let's solve for x. And that is an A out here. A lot of times they're using lowercase letters, so we'll just make sure that it's that way. All right, now here's the big difference on this one that we had on the other ones. Now you don't have just one x that you're trying to get. Now there's two x's in there, right? So anytime you've got more than one letter that they're asking you to solve for, you have to get both of those two things on the one side by itself, and then everything else has got to be gone. So for this one, because you've got an x that's in the middle of this thing, you're going to have to do distributive property with an a to start with. So we're going to do a times 2x. And where you put that a, it doesn't matter. I'm just going to put it first in front between the 2 and the x. If you put it at the end, if you did 2xa, that would be fine too. Where you put the letters is not really that important. And then we'll do 12 times a here. So we're doing distributive property to start off with. Okay, so we've got to get these x's together, which means to do that, we've got to get rid of this 12a. So since it's a minus 12a, to get over here, we're going to move it over to the other side and we're going to do plus 12a. That way, that'll cancel out. And we'll do b plus 12a. And same thing over here. It doesn't matter if you do b plus 12a or 12a plus b. As long as you've got the b is positive and 12 is positive, which one's first, it does not matter. Either one's fine. Okay, now here's where we go back to the question we had just a few questions ago. I think the very first one we looked at. You've got a 2ax and a 3x right here. We got the 2x's. We've got to get it so that there's only one x out there. So is everybody okay that over here on this side, if we cover up the b plus 12 for a minute, you've got 2ax and 3x, right? They both have the x in common. So we're going to do like we did on this problem. I think it was that very first one we did. Yeah, when we did that very first problem back here. How we took out this greatest common factor of 2 back here. We're going to do the same thing here. Since they both have an x, we're going to take that x out. And then tell me what you have left over once you take the x out. We'll take the x out here. That's going to leave you with a 2a. Take the x out here. That's going to leave you with a 3. So anytime that they're asking you to solve for a specific variable, anytime you see two variables, it's almost always going to be like that. You're going to take out the variable and you're going to tell me what's left over. Once you've done that, this is x times that 2a plus 3. So to fix that, it means we've got to go back and divide by the 2a plus 3. And since it was in parentheses here, if you want to go ahead and put parentheses around it, that's absolutely good. That's fine. If you don't put parentheses around it, that's fine. Just remember that they were there. So if you know, as you're going through that one, you've still got to think about it. That way, those cancel out. Get the x by itself. And over here, again, these have to be exactly the same. This is 2a plus 3. This is not anywhere close to 2a plus 3. And since this one's in parentheses, the only way to cancel anything is you have to have another 2a plus 3 up here that would cancel. That's totally different, so we're going to leave it just like that. And with a lot of these questions, when they're asking you to solve for a specific variable, you're probably not going to have a lot of canceling at the end right here. More than likely, it's going to be left with just a bunch of variables and numbers all over the place. So you're probably not going to get a lot of cancellations on those. And that's fine. They don't expect you to cancel it. They just want you to get the x by itself. Or, you know, if you're in chemistry, they want you to get the, you know, the sodium by itself or the nitrate, whatever it is that you're working with. You got to get that one thing by itself there. And somebody usually asks, well, what if I left the parentheses in here? That's fine if you did. Again, this should be a multiple choice question. So, you know, it'll always look something like this. It may be that you might have 12a plus b over 3 plus 2a, but either way you go, you'll have a 2a and a 3 on the bottom. You'll have a 12a and a b on the top. Exactly where they are, not that big a deal. Okay, so there's the division. We're solving for those equations. And I think the last couple of things, and if you've got some more, we'll look at some. If somebody's got something specific they wanted to look at. I know one of the things that popped up a decent amount was the evaluate when they gave you an equation or they gave you some different numbers and asked you to plug in and solve for the variables or to evaluate using the variables. For this one, let's give you a couple of different options. Oh, hang on. Sorry about that. Try that again. Let's say volume is equal to pi r squared h. And they tell you in the problems, go ahead and use 3.14 for pi. I know you have a pi button, and it should be okay even if you use the pi button. It should give you an answer. It's really close to it. And then they will tell you that the radius is 5.5. And your height is equal to 8. And they should tell you to evaluate, or they may even tell you to find the volume. Either way they go. Basically, you're just taking the numbers and plugging them back in and working through it. All right, if you have any decent calculator that's scientific, we were trying this earlier with the The calculator I had on my phone didn't do the parentheses quite as well, so it didn't work out this way. But if you've got any kind of decent calculator, you can probably look up one that's online. The one that's on your computer, is probably not as good, but a lot of times you can look up, just get an online calculator somewhere that's a scientific calculator that you can use for free. Take the numbers that you have here, just plug it back into the equation. And here's the biggest thing, and I'll tell people whether they're in high school, when I'm teaching at Calhoun, we're doing college, anytime you plug in a number, put it in parentheses, because that should take care of almost every question that you have to do. Pi is 3.14. The radius is 5.5. And your height was 8. And if you've got any kind of scientific calculator, especially the ones that have a decent sized screen on it, whether this one is a Casio, usually I'll have, once we get rolling in here, start doing a lot of work in class, we'll have some Casios or some Texas Instruments on the boards. Basically, just take those numbers and plug it right in with parentheses where you've got the numbers and see what happens. So we've got 3.14 times 5.5 squared times 8. Hit enter. And depending on the calculators, for the Casios, a lot of times they'll give you this number that's a fraction, and you're like, wait, but there's not a fraction answer. All you have to do is there's an SD button that's right here, right above the delete button. And in different models, they're maybe different places, but they're usually right about in the same spot. Hit that SD button and it gives you the decimal number. That's 759.88. And some people go, what if I accidentally use my pi button? Okay, it should give you an answer that's really close to that. The pi button is right here, times 5.5 squared times 8. Now, this one again gives you the answer in pi, which again, we want the decimal number, hit that SD button again to get it back to decimal number at 760. So if you accidentally use the pi button, it comes out to be 760. There's only going to be one answer that's close to 759. I'm not going to give you one answer that's 759 and the other answer is 760. No, the answers are going to be like 250, 760, 1,000, and then like 827 or something like that. So there's only one answer that's going to be close, whether you use pi or 3.14. That either way that you go is fine there. Not trying to get tricky on you, just making sure that you know what you're doing. Okay, and the other type of evaluate questions where you didn't have a formula, it was basically just something like this. You had 4x squared plus 3a plus b. Okay, less formula, more of just, okay, here's an expression, here's the values, plug it in and see what you get. Same thing, if you've got a good calculator, you just go ahead and plug in the numbers with the parentheses around the numbers when you plug it in. And people may go, why do I need the parentheses around the 5 there? We don't, but just to be on the safe side, you can go ahead and plug it in. So we got 4 times negative 2 squared plus 3 times negative 4 plus 5. Good night. Now, if somebody says, what if I don't have a really good scientific calculator with me when I get home? Okay, just go through your basic order of operations, which is what the calculator would do. The biggest thing you have to do is you have to do the parentheses first. If there's a big parentheses with that one, which we've got parentheses here, but that just means multiplication. Okay, so next thing is you do your exponents. You do negative 2 times negative 2. That would make that a 4. Once you have your exponents gone, now you're going to do your multiplication. 4 times 4 is 16. 3 times negative 4 is negative 12. And then once all the multiplication and division is gone, then the last step you get to do adding and subtracting. 16 minus 12 is 4. 4 plus 5 is 9. Okay, so if you have a calculator, it goes a little faster. If you don't, again, it's going to calculate those in that order when you're going through the steps and going through the order of operations. Okay. I think that's what they really want you to know, how to do your order of operations, a little less on plugging in the calculator, but again, you still need to know how to plug in the calculator. It does help out sometimes. Okay, and I think that was the main things that I had there. Does anybody need to see a slope problem? Calculating slope. If you'd like to see one, just give me a nod. If you don't want to see one. Formula for slope. The one they probably gave you was y1 minus y2 over x1 minus x2. You want to do one? You good? Okay. Now, actually, I think that's the formula I use. I think they actually gave you this formula. Either one of those two is okay. I just like putting the ones first because to me it makes more sense to put the first thing first and the second thing second. But either one's fine, whichever one you use there. The one thing I did notice on a couple of problems is they would have you find the area of a figure and they didn't tell you what the formula was. So you may have to do a quick Google search. If you forget what the area of the formula is that you're working with, you might have to do a quick Google search to make sure you get that formula when you're doing area or volume or something, because it was about 50-50. Some of the problems that were evaluated, I think they gave you the formula. Some of the problems where you had to work with it, they didn't give you the formula. So it's kind of back and forth when they go through those. Some they did and some they didn't. And I think that was about it. Again, the long division, which we did some of those yesterday, there's a few problems of that on there. There's some slope problems, which everybody said they seem like they're okay there. I think there's some finding an x-intercept or y-intercept where you just look at the graph, tell me where it is. And other than that, I think that was everything was some variation of those different problems that we looked at there. So.